G'day. In my last video I showed you how to construct Babylonian numerals on a clay tablet using a stylus. Not everyone wishes to use clay, and what I propose to do in this video is to continue developing our understanding of Babylonian numerals, but I'm going to use a tub of ice cream, partly because it's easy to smooth over and start again, and it's somewhat bigger than a tablet, so it's easier to photograph, and my neighbour's children will enjoy it afterwards. Why are we learning Babylonian numerals? Well, for two reasons. One, it's just fascinating to learn about how people thought and how people perceived the world and calculated years and years ago, thousands of years ago. But it also helps us understand how our number system is put together. This is one of a series of videos that I'm making about base arithmetic. We happen to use a base 10 system. The Babylonians used a base 60 system. So we're going to discuss base 60 in this video, and in subsequent videos we're going to look at a few other bases and how they're used even today. So let's get going. Well, here we are with a tub of ice cream. I'm using a credit card that I've cleaned, and, well, not a credit card, but something like it. And we're just going to, first of all, remind ourselves how Babylonians constructed their numbers, and then we're going to perform a simple addition. Now, imagine this is our clay tablet. I'm going to divide it into three lines, or three areas, top, middle and bottom. And in the top we're going to construct some numbers. Now, you might remember that the Babylonians created numbers like this. That would be 3, 4, 5, 6, 7, 8, 9. And to create 10, they would press in this way. We're going to, it's a little bit tacky. That'd be 20, 30, 40, 50. So that would be 59. Remember, once they got to 60, they went to the next column. So let's call that a 1 in the next column. Let's put 2 there. In the next column, let's put a 10 and a 1. What we're going to do is add it to another number. I'm going to add it to 34 and 55 and 43. So if the Babylonians were adding these numbers, they would collect these 9 and these 4 units. Now 9 plus 4 is 13, so they would actually have 3 units in their answer, and 1 bundle of 10, which they'd add on to these bundles of 10. Now they've got 5 of them here, 6, 7, 8, plus the 1 from this this bunch from the units here. So what's that? 5, 6, 7, 8, 9. Now they can't put 9 bundles of 10 here. The maximum they can put is 5. So how do they divide up that 9 bundles of 10, that 90? They know that they can put a unit over here worth 60 of them, so there are only going to be 30 left. There's our 30. And they carry 1 over. So let's count up our units of 60. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They count up their bundles of 10. There were none here, and I think I've got 5 of them there. So 1, 2, 3, 4, 5. Nothing to carry. They've got 1 unit here and 3 here, so they would have 4 in the answer. And they'd have 1 bundle of 10 and another 4 bundles of 10 would make 5 bundles of 10. Not quite enough to make a carry. So this answer, as they would interpret it, in their units column would have 33. In their 60s column would have 58. And in their 60 lots of 60s column, their 3600s column, would have 54. So this would be 54. That's 50, isn't it? Yes, 58 and 33. Now, of course, in our number system, we would have to convert that to base 10, and we'll talk about that shortly. But this is how an addition was done, and we're now going to look at it on a whiteboard, because this is already getting soft and a bit tacky. But by the way, this is not a bad idea if you wish to do it at home, if you're homeschooling, or if a teacher's got a small class and wants to be a bit creative and let people have some ice cream after the lesson. But I'm going to clean this up now. The Babylonians, of course, when they wanted to rework anything, simply smoothed it out and started over again on the clay. It was only when they let the clay bake in the sun that it became permanent. Now I've reproduced on the whiteboard exactly what we did on the chocolate ice cream. And that is, I have the same numbers written in Cuneiform in the Babylonian number system. And you can see here that we have 9 of these units and 4 of these units, and together they made 3 with a bunch of 10 that we added on. These 5 jabs here means 50, and another 3 plus the extra 1. 5 and 3 is 8 and 1 is 9, which is an extra bunch of 60, because this is the 60s column with 3 left over. Now, to make that clearer, we're actually going to convert this to our decimal system, almost. And that is, in blue, I'm going to write these numbers underneath so it's a bit clearer. This was the number 59. This was the number 2. This is 10 and 1 is 11. This is the number 34. This is the number 55. Here's a 43, 33, 58, and 54. Now, before I proceed, I'm going to explain the columns a little bit more. I mentioned in the last video that in the 1600s, in the 17th century, as scholars were writing their treatises in Latin about this kind of mathematics, they actually devised a system to keep track of which columns were which. And the system they used, the system that John Wallis adopted and improved upon, was one where they marked the units column with a little 0, and then used Roman numerals to indicate which of the fractional columns were being used. In this case, this would have been read 11 degrees if we're talking angles, or if it's time, we would call it 11 hours. And these would be our 2 minutes and 59 seconds. Now, the units didn't have to be this column. They could have been this one or this one if we were doing other work in other parts of mathematics. But with Babylonian mathematics, this column was always worth 60 of those, and this one was always worth 60 of those. So if this was the units, these were 1/60th of these, so we're getting smaller, and these are a 60th of these. So these are very, very tiny, 1 out of 3,600. If the units were over here, this column being on the left was worth 60 of these, and Mr. Wallace, I'm putting an image of him over me now, but Mr. Wallace, I'll stand on this side, used the same notation for the columns this way. That was a particular adaptation that he made. He produced two very, very famous books, by the way. One was called Arithmetica Universalis, which he published in 1656, I believe. And some of you may recall that Sir Isaac Newton once said, "If I have seen further, it's because I stood on the shoulders of giants." Well, I believe one of those giants was John Wallis. He was a very accomplished mathematician. And in his undergraduate years, Isaac Newton studied that particular book written by John Wallis, Arithmetica Infinitorum. And in it are some of the concepts that Sir Isaac Newton used to develop the infinitesimal calculus. So the seeds of it were in John Wallis's writings and other people's writings at the time. Sir Isaac Newton didn't invent the whole thing. He certainly made incredible major advances in the field, but it had been discussed in its geminal or seminal form for quite some time beforehand. The following year, by the way, John Wallis was about 40 years old when he published that work. The following year, in 1557, he published another work, Mathesis Universalis, the universal studies or the universal sciences, or science. It was a challenge that Gottfried Leibniz on the continent was also interested in. This was trying to work out a universal way or a universal language to understand existence in the universe and everything. And this was part of John Wallis's contribution to the field. In it, by the way, he not only invented this notation on the left, prior to him they were doing it on the right, but he also developed the number line idea. So those of you in high school who are learning number lines, John Wallis invented that idea. He invented the symbol for infinity. He did a lot of work on infinity. In fact, he did that in the previous book. He also followed on from René Descartes, the French mathematician, who wrote powers in our form, which is a 2 with a little 3 to say 2 cubed. But it was John Wallis who developed that into fractional and negative indices as well. So those of you who are studying indices also have to understand that that came from this same book in 1557. So quite a remarkable man. We're going to replace these with something a little more useful to us. Let's call this our units, or our ones column. I'll write units above it. I'm not sure whether that just fits on the screen. This column is worth 60, so I'll rub these off, otherwise it'll get confusing. So it's worth 60 times them, and this column is worth 60 of those. Now 60 times 60, or 60 squared, is 3,600, so you can think of it in any of those ways. So when we have a 2 in this column, it's actually worth 2 60s. When we have 11 in this column, it's actually worth 11 of those. 11 lots of 3,600, which you can understand is a very, very large number. What is it? 39,600 in our numbers. So let's now, knowing this, add our numbers up. We have 59 and 34, which we would add, I might even change colour yet again, which we would add 4 and 9 is 13, carry the 1. That gives 6 and 3 is 9. Now remember, as we move to the next column, we can only take a bundle of 60 with us. So if we take 60 out of this and carry it over to this column, we leave 33 behind. They're the units that are left in the units column. We managed to get an entire bundle of 60 to come across into this column when we write it as one bundle of 60. Now let's add these up. We've got two bundles of 60 here and 55 of them here. That makes 55, 56, 57, plus the one we brought over is 58 bundles of 60. And in this column we have 43 and 11 bundles of 3,600. and 43 plus 11 is 54. So in some ways it's a little bit easier to see writing decimals in those locations, which is exactly what the mathematicians like John Wallis were doing in the 1600s. They got rid of this notation that the Babylonians were using, but kept the columns and the number system. Now, I'm going to get rid of that, and I'm going to perform two calculations with you. One of them will be adding angles, and the other one will be adding time, because both of them use this system. Okay, I realise, by the way, I also forgot to show you a small section from that second book of John Wallis's, the Mathesis Universalis, in which he shows that notation for the columns using the 0 and the Roman numerals. I'm putting it on the screen now so that you can see how in fact it appeared. I'm not telling you porkies. Now for our first calculation we're going to add some angles together. We're actually going to use that same notation. Let's imagine I want to add 281 degrees, 46 minutes and 23 seconds to 43 degrees, 34 minutes and 51 seconds. Notice, instead of just using them as headings, we're actually writing these symbols on each of the lines. We're keeping our degrees, our minutes and our seconds lined up. And just to remind ourselves, these are worth units. Now because we're going to the right of the units, these are worth fractions. These are 1 over 60s, and these are 1 over 60 times 60, or a 60th of a 60th, which is a 1/3600th, very tiny fraction of an angle. And we can go further. Now, if we add these, let's see what we get. We get 1 and 3 is 4, and 5 and 2 is 7. So we actually get 74, which is too big to fit in this column, because the maximum we can have in a column is 59. Once we get to 60, we have to take a bundle of 60 to the next column. So if we take a bundle of 60 out of this, we'll put it over in the next column, and what's left if we take 60 away? We've got 14 left in the seconds column. Now in this column, let's add these up. 46 and 34 is 70, 81. Now we can't fit. I'll put the one up here. No, I don't want to confuse it with the minute symbol. Put the one here, but we're going to get a total of 81. If we take a bundle of 60 out of that to put in the next column, which I'll do, actually I'll put it on the side here, what's left if you take 60 out of that? The answer is 21. And it's minutes in the minutes column. And over here we have 281 degrees and 43 degrees and another 1 degree, which was made up of all those minutes added together. Let's add them together. 1 and 3 is 4 and 1 is 5. 8 and 4 is 12, carry the 1. So the answer will be 325 degrees, 21 minutes, 14 seconds. This is how angles are added manually. And I know a lot of you are doing them on your calculator now, but it's actually worthwhile knowing the procedure. So let's perform a similar calculation by adding some time measurements together. Now, unlike degrees, where we can have angles of in the hundreds, thousands, tens of thousands of degrees, because the angle just keeps going round and round and round, with time, when we get to 24 hours, we have another name for that, and we call them days. So I'm going to add this. 2 days, 5 hours, 23 minutes and 51 seconds. And to that I'm going to add 5 days, 22 hours, 41 minutes and 18 seconds. Now, before we start, how many seconds are there in a minute? There are 60, just like the Babylonians used. How many minutes are there in an hour? There are 60. So one of this bundle is worth 60 of those. How many hours in a day? Not 60 anymore. The number of hours in a day is 24. So you can actually see now that sometimes when we're doing base arithmetic or calculations using bases, that the base can change in the middle of a calculation. This is very common with imperial calculations. Feet, inches, yards, miles, pounds, shillings, pence, things of that ilk. Ounces, pounds, stone, hundredweight, tons, and I'll be showing a video on each of those so you can see how this pattern is used. But let's perform this calculation. 51 and 18. Well, 51 and 18 makes 69. So we have 69, I might change colour here, we'll use red. So we have 69 seconds. Now, that's more than 1 minute. 1 minute is worth 60 of them. So if we take 60 of those, our bundle of 60 to the next column, we put 1 minute, and then we take the 60 seconds away from this and leave 9 seconds remaining in that column. That's our seconds column. Now our minutes column, we add these. We've got 60, 4, 5. Now again, I've deliberately done this, of course. 65 minutes is more than an hour. It's more than will fit in this column. So again, because an hour is worth 60 of them, we take a bundle of 60 over as 1 hour, and we take 60 away from this and leave 5 minutes. So let's look at how many hours we have. We have 22 and 5 is 27, 28 hours. And we look at the next column, which are days, and the days are bundled into groups of 24 hours. That's more than 24 hours. So we can take one bundle of 24 hours over as a day, and what's left over if we take 24 hours from here? The answer's 4 hours left. And what have we got here? 5, 6, 7, 8 days. And that's how a calculation is performed with time. Now, later in this series I'll show you how that's done with subtraction and how we can divide and multiply using the same kind of notation. But for the moment, it's important to understand this, and it will help us understand our decimal addition and subtraction very clearly later, and also get very fast at it. I'm only going to do the one example, and I'll leave it at that for the moment. If you found this video productive and helpful to you, then please leave a comment. Certainly click the like button, and I'd very much appreciate it if you subscribed as well. Thank you for watching.